Hello everyone, this is Himanshu, and today I'll be solving one of the problem from the lead code, basically neat code that is blind 75. So yeah, just have a look. So this is the problem that is called valid binary search tree. So it's like given the root of the binary tree. So this is the binary tree, and we have the root. We have to return true if it is a binary search tree. Otherwise, we have to return false. So binary tree is basically a tree in which, given a node, the left side of the indexes will be less than or equal to the parents, and similarly, right side of the nodes will be greater than or equal to the parents. So okay, I think here it is defined that. So since all the elements are unique, I believe, so the left subtree of every nodes contain nodes with less than node key, and the right is contains less than the right key. Okay. So here this is false because this 2 1 3. The left side is greater. Here it is true. Okay, I understand. So what will my method will be? So here I think I will check. Uh, I will check at the root, and by checking the root, what I mean is that in the left subtree, subtree, I will ensure that all elements are less than less than root, and in the right subtree, I will make sure that all elements are greater greater than root. Sure. So this is what I need to ensure. Uh, yeah. Now the question comes like, is it possible for us to if that is greater that also should be less than the parents, right? So what I meant here is that let's say here this is the tree representation or the representation of the binary tree. Uh, uh, so let's look here. So if we uh, look at this, let's say this is the binary tree that we have. So this node, we don't want this node to be bigger than this node or to be bigger than this node as well. So there is a specific constraint that is needed to be maintained that any of the indexes in that row will also be less than the parents of that node. So there are three conditions to be checked. Right? So even if it is greater, but it has to be less than that node. I think then if these three things are equivalent, then I think uh, yeah, we can move forward. So given a node, if left side is smaller, uh, yeah, it should be less than this one and should be greater than this one, but the greater than should be less than the parent one, and uh, yeah, so it should be less than parent of parent, and it should be greater than parents. It should be greater than parents parents if that is the left node. So the left node should be greater than parents. The right node should be greater than parents, right? I think one way is to just check if we traverse the binary search tree in one, two, three. Okay, so if we traverse the binary search tree in level order traversal, uh, in order traversal, right? So left, then root, and then right, and then we go with the parents. Uh, what I think that it should form a shorted array. Yeah, and if that is the case, I think that that is the valid. So if you see, this is uh 1 2 3, but this is the post order. But if you go by in order traversal, I think you will get the correct. So I think what we have to do is uh intuition is to do the in order uh traversal and check if if the output is if the output is sorted. So yeah, this is what I'm thinking. Yeah, let's should we go forward? Mm. So first let's do this way and then uh we'll move forward to the one. I think there's also one better also. So let's say if root uh if root is none, then we just return true, right? Uh that is what we have to return. We have to check root dot right. I think so we need to check root dot left as well as in root dot right. Uh yeah, in that we have to check if root uh dot left and if root dot right gst, and if root dot left is valid, uh, and if root dot left exists, and then if root dot left exists and root dot left uh, dot wall, let's say, is greater than root dot wall, then we just have to return false. That's correct, right? Root dot left dot wall. Similarly, if root dot right and root dot right dot wall is less than root dot wall, we have to return false. Yeah. Uh, yeah. I know this will give me an incorrect answer, but still I will just return. If both of these conditions are, let's say, true, then we just have to return is valid. Root is valid BST. Root dot left and is valid BST. Root dot right. So what I expect this to give us incorrect results. Yes, I mean self. So I want this to fail because I have not considered the parent aspect of it. So it will, yeah, but here it should fail. Yeah, I thought that true is failed. So output is true. Otherwise, so okay, greater than equal to will also work. Do- Okay, this is 16th one, right? So 0 minus 1000 plus 1000, and then Okay, so here there's minus 1000, there's plus 1000. It has null null. Nothing is zero. Yeah. So this is basically doing what we call as parent checking, because you also have to check the parents from that node if the parents is not lively. So given that is incorrect, let's move toward now uh, how we can do it using in order traversal. So we'll just this will also return as the sorted one, right? What if 2 to 2? That is also sorted. Now I think I should create one parent, and then we also have to check. So if this is the left child, okay. So if the root is left child, we will look. We'll check for the if the root is the left child, we'll check for the right child, and if the root is the right child, we have to look for the left one. So let's start with that implementation. So this is our tree, and yeah, as obvious, if root is none, let's create a dictionary. Let's create a dictionary, and the dictionary create a dictionary with two elements that we'll put as root and its parent, and we'll check if root is none. Uh, Here return true. Then we'll check if root dot left is greater than or equal to root. You just return false. Root dot left is greater than false. And if let's say root dot left and if let's say root dot right and root dot right, let's say less than or equal to root, then also return false. Okay. And here what you can do is uh need for null as well. Parents. Yeah, there's no issue. We can just put null as the parents, and then we can t of root dot left. Okay, sure. Let's check it there. So we'll just d dot append. What will be appending? We'll be appending. Let's do nothing here. Just do d dot append left root which will be root dot left, uh, and just append the parent name, right? And d dot append root dot right, and just append the parent name, right? Okay, and then you have to return check function that will take root dot left and root dot right. Now let's go here. Define a def function that will that is called check, and it will take root dot left, left, and it will take right, and now it will do the operations. And now what kind of operation will it do? Uh, so since it has two and it is in the form of pair, so yeah. So okay, what we have to check. So if left, okay, so let's define L equal to L comma, okay, so we basically have we also have to pass dictionary, so that will be D, right? And left is proper inode, right? We'll check if left dot left, just make it LNR. If L dot L if L dot L if L dot left is less than L dot wall is greater than or equal to L dot wall, and L dot right, okay, and L dot right uh, is, let's say, less than or equal to, obviously, L dot wall, we have to return false. I think there is also one condition that we need to check, and this is if, since this is a left child, right? But what about their parents? Okay, I don't think we need to care. So what if L dot ref left does not exist, right? That can also be the case. And what if L dot right does not exist? And what if even L does not exist? So if L is none, I think we just have to return true, right? Similarly, if R is none, what we have to do is to return true. This is also done. And here, what we have to do is we have to check if L dot left, right? And L dot left is greater than or and L dot right, and this happens, right? And after that, there's one more condition, that is and and L L dot right need to be less than so okay, is less than, then it is a shoe, and L dot right need to be less than. So what we cannot afford is being L dot right greater than or equal to the parents of L. So that is D of L dot wall. So this is what I think. It should also be need to can afford to greater than or equal to the wall, right? Then we just have to written false. As simple as that. Similarly for right. So if I think we can just copy and paste this. So here if you see if r dot left, we want the r dot left if exists, and then r dot left is has to be less, right, is greater than or equal to r dot wall, and r dot right is less than or equal to l dot wall. R dot right is less than or equal to r dot wall. Right one has to be less. Dot left is less than or equal to dr dot wall, the parents wall. That is also false. And here what I will do is I will just push back. I'll just do d of l dot left equal to l d of l dot right equal to l d of l of so this is the for condition, and then I'll just return. Check. Yeah, and this is what it should be. I'm looking for invalid append. So, this is- so this is correct. Here output is true. Oh, my God. I know that I will need to check for none. Left is none. What can we do? Yeah, there is also a good approach. Float minus INF. Float minus INF. Float minus INF. So I can just return validate root comma float minus INF float minus INF, and here this should be bool valid. यहाँ पर क्या कहेगा? Handstrucks root IMF node left right. So if node is none, return true, right? If node uh, if node dot left is greater than or equal to dot left, equal to node or node dot right is less than or equal to node. Okay, bye bye.